on this topic in Ethiopia for the last 2 years. The clear motivation for this originates in the objective of country programs that IFPRI has in African countries, and that is to promote evidence-based policy choices on the part of policymakers. And the topic that we have chosen from among the list is agricultural productivity, which we have been hearing yesterday and today is central to a lot of development issues in Ethiopia and more broadly in Africa. So identifying the source of productivity growth and also the constraints to such growth would be very helpful, and that is the underlying motivation of the study. As I said, I will report some of the findings some of the findings relevant from our study. We'll start with data and methods very briefly. We used two data sets, one a nationally representative annual agricultural sample survey conducted by the Ethiopian Central Statistical Agency over the last 2 decades. The other is the Ethiopian Rural Household Survey, which is a collaborative effort by a number of academic and research institutions, including the School of Economics of Addis Ababa University, IFPRI, Oxford University, and others. And this has been going on again for about 20 years, more or less, and 7 rounds of survey of the same households in these neighborhoods have been conducted. In terms of methods, I briefly describe 3. These are gross decomposition, gross accounting, and stochastic frontier analysis, all based on this schematic link between output growth and its sources. The first source of growth, of course, is the expansion in input use, and the difference between change in output and change in input use generally represents change in what is called total factor productivity. And again, the exact combination of what TFP is in part a matter of taste. Some of the components that I listed on the right-hand side sometimes are considered distinct. Efficiency in particular is considered distinct from TFP, but that's, I believe, a matter of test. So using this setup, we try to apply the techniques of decomposing output growth in itself, linking output growth to input use growth, and then ultimately to change in the components of total factor productivity. Everybody heard a lot about recent performance of the Ethiopian agricultural sector, and the data from CSA clearly shows that. In the last 5-6 years, output growth averaged 9.3% per year, and that in effect is a 50 percentage point growth in output. Yield also has been expanding, as well as area. Yield has been growing at the rate of 4.4% per year on average, the same period for all crops, and a bit higher for grain. Now, the question, of course, is what are the sources of these expansion? And the significance of this question, of course, lies in the interest that is motivated by the desire to sustain this growth. It's particularly high growth rate, and whether this can be sustained and in what manner, of course, is a very important question. And that is part of the motivation for this study. From what we have seen from the data and using different techniques, the first observation is that a lot of these, significant fraction, almost 50% of the output growth originates in expansion of cultivated area. The remaining 50% is divided between increased use of other inputs, such as number of labor, if you like, measured by number of holders, and livestock or draft power, which represents non-land capital in our case, or we can call these traditional inputs. The remaining is originates in total factor productivity. The growth in other inputs is reported on this slide. Sorry for this, a lot of information in one slide. The idea is that there is growth in the application of modern inputs, but it is not as rapid as the expansion in traditional inputs, including cultivated area and labor. That's the main point. A similar story, somewhat more nuanced perhaps, is obtained from the analysis of the Ethiopian Rural Household Survey data. Again, covering roughly the same period, we observe expansion, significant expansion in the real value of output, about 8% per year, and area grew even faster, while the application of fertilizer also in quantity terms has expanded rapidly, particularly towards the end of the period. However, the real value of output has also been per hectare has been growing until the last survey, which happened in 2009. In terms of sources of growth, again, traditional inputs dominate. The size and quality of cultivated land is a major source. Draft power is another, and labor also important determinant of growth. As usual, we are dealing with rain-fed agriculture, so amount of rainfall achieved is an important determinant. What happened to total factor productivity? So we talked about the input sources of growth, if you like, and different techniques have been used. Just to briefly report some numbers. If one uses a growth accounting framework where the TFP in effect is a residual, we observe using CSA data for agriculture as a whole, it grew by 3.7% in the 5-year period between 2004 and 2009. Similar specification using CSA data, but adopting a stochastic production frontier generates roughly the same annual growth rate in total factor productivity, 4.66%. Now, it is likely that these growth rates would not be sufficient for the targets that the growth and transformation plan set for the agricultural sector. The picture, however, changed when we consider total factor productivity growth using the Ethiopian Rural Household Survey, and that is actually a decline. Total factor productivity actually declines. In terms of efficiency, measured now relative to the best performing households or zones, so this is technical efficiency, and where the average, this is a comparison between the average farmer and the best farmer, if you like. And using CSA data, we obtain a national average technical efficiency level of 0.72. So the average farmer is 72% as efficient as the best farmer. And this has been growing over the years at the rate of 1.2%. There are considerable regional differences. The level of efficiency ranges from 0.5 to 0.9. Similarly, the growth rate varies. When we come to the Ethiopian Rural Household Survey data, in principle, similar picture is drawn. Average household level efficiency is now 0.52. It is lower than the national average, although its growth rate is roughly the same. And the differences, regional differences, are a bit narrower than what is reported and what is obtained from the national data. So what does this suggest? Let me start by summarizing. First of all, we have noted that the bulk of growth in output originates in area and traditional input expansion. Rainfall matters, as to be expected in a rain-fed agriculture. Modern inputs are yet to contribute as much as expected to output growth. And we observe that the extension system is valuable to farmers in both the RHS and the CSA dataset. This suggests that future growth has to come from increased TFP. And what is the potential for increasing TFP? First, if we think in terms of efficiency, improving efficiency, the national data suggests that there is limited room. The average is 72%, and this would be lower, even higher, sorry. This would be higher if we if we drop one of the regions which has the smallest TFP. This rises to about 90%. So that suggests little room for enhancing efficiency. The RHS data suggests that there is a lot more room. The question, however, is how to do it. Before I talk briefly about that, I want to emphasize a caveat here in making the comparison between the two data sets, between the two results. First, the data. The data used for the CSA analysis is at the zonal level. There are about 50 zones involved in that analysis, and the data is nationally representative. It's collected by the national agency responsible for such exercises. So the RHS, in contrast, is a small selected sample survey, which is not nationally representative. That distinction has to be made, kept in mind. Second, the concept of efficiency is a farm-level concept. We have used that at the zonal or a region, special region level. So that would create some difficulty in comparing and interpreting the results. So that is the caveat. In any case, so if there is some room, and that room, realizing that room, exploiting that room for improving efficiency is tricky. Education, training, and extension services perhaps are important. So the challenge is, how do you exploit that efficiency gap? Second, there is the question of adoption. And we have sufficient evidence that indicate that the returns to some of these modern technologies, such as fertilizer, appear to be low. The economic returns appear to be low. We have calculated value-cost ratios, which appear to be less than 2 for most of the crops. So the question of input subsidy arises from, among other things, and that's one challenge, targeting and others that we heard from yesterday. The second challenge is availability, and this particularly refers to seeds. There is still an open question whether the right seed varieties are available, and whether and how an efficient distribution system can be built. Thank you very much.